Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you find area of the green shaded triangle? Take a moment to study the figure. Then let us uncover the key geometric ideas that make the solution click. Inside the blue square, the green triangle EPC is the target. We need its area. The next scene will reveal the whole square area that sets the scale. The blue square IBCD has area 110 square units. Keep that as a whole figure given. The green answer is not shown yet. The matching strikes show E is the midpoint of segment AD and F is the midpoint of segment AB. The source construction uses both midpoint facts. Extend the line CF beyond F until it meets the extended topside through A and D. Call that source proof point T. This is the one auxiliary construction the original proof needs. Triangles IFT and BFC share vertical angles at F, and segment AT is parallel to segment BC because they lie on opposite sides of the square. They are similar. Since segment AF equals segment FB, their scale factor is 1. So segment AT equals segment BC, one full square side S. Also, segment EA is half a side because E is a midpoint. Aha! Base segment BC and one full square height make EBC half of ABCD. Triangle EBC therefore has area 55 before we know the green fraction. We now know the containing triangle EBC has area 55. The remaining task is to locate P's split along segment EB. Along the extended top rail, segment TE is segment TA plus segment AE, one full side plus one half side, or 3/2 S. Now compare triangles TEP and BCP. Their sides segment TE and segment BC are parallel, while the lines TPC and EPB cross at P. The parallel line angles match, and the angles at P are vertical. Therefore, the two triangles are similar by angle. Corresponding sides give segment EP to segment PB equal to segment TE to segment BC, which is 3/2. Aha! The source extension segment TE exposes the 3:2 split of segment EB at P. That determines the green fraction of triangle EBC without solving coordinates or revealing the answer. Triangles EPC and PBC share the same altitude from C to line EB, so their areas follow the same 3:2 base ratio. The green triangle is 3 of the 5 equal ratio parts, so it occupies 3/5 of triangle EBC. 3/5 of 55 is 33. The companion triangle has the remaining 2/5, 22, and 33 plus 22 returns the containing area 55. So the area of the green triangle EPC is 33 square units. That completes the solution. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.